In this program, what we're going to do is we're going to take a look at the assignment operator. The assignment operator is a different way of representing typical operations that you do in Java. So, for example, I'm just going to put a note here. Most operators have an assignment operator equivalent. So here's one example. So imagine we had a variable x and we wanted to add 5 to the current value of x. So the way we would write that is x gets the value of x plus 5. So what this means is x increases by 5. Essentially what happens here is imagine x is 3. So the program figures out, okay, well, what is 3 plus 5? That'll be 8. And then the result is stored in x here. Now, the other way of representing this is like this. X plus equals 5. So what this will do is x increases by 5. And this is, useful for most of the operations that we commonly use. So we could do x minus equals 5. So this would be x decreases by 5. You can similarly do x multiplies equals 5. You can do x divide equals 5. This is useful for a whole bunch of things because, one, this is often a little bit easier to read than this. So one of the ones that we're going to be doing in this program is we're going to make use of modulus. So what is modulus? So this is, modulus is often the remainder operation. So if we wanted to find the remainder of a calculation, so imagine we were doing a division, so we'll have x gets the value of something like 13 divided by, let's say 4. Okay, and then what we wanted to do is also get a remainder value for this. So the way we do that is r, which for remainder, gets the value of 13 modulus 4. So this one would be 1. And if we were doing this as an integer, this would be 3. So the value of this would be 3, the value of this would be 1. Now there's a whole bunch of applications where we use modulus. We use it for converting numbers from decimal into binary. We use it for figuring out the remainder after we fill packages to be sent. Here's an application that we're going to do, and so program along with this. So we're going to start with a number. This is going to be a 5-digit number, so we're going to call it number 5. And all you're going to do here is you're going to put your favorite 5-digit number. Most people are aware that my favorite 5-digit number is 58,247. Just you can either go along with this or you can pick your own. So this is going to be a 5-digit number. And what we're going to do is we're going to reverse this, int reverse. There we go. And what we're going to need to do is we will often need to initialize values that are going to act as counters or accumulators, as we're going to see in this program. And what we need to do is we need to process this 1 digit at a time. So we're going to go int digit. There we go. So we're going to start with, your favorite 5-digit number. Make sure that it doesn't have leading zeros, I suppose, because it won't be able to represent those as a reverse properly. And then 0 is the reverse because we haven't constructed any of it. And digit is the individual number that we were going to process. Okay. So what I want to do is I want to take this 7 and I want to put it as the first digit of reverse. So it's the last one here and it's the first this way. So what we're going to need to do is we're going to have digit get the value of number 5 modulus 10. So remember, if we divide something by 10, typically we lose a decimal place. Now, if we take modulus 10, we are going to get that digit that we essentially removed there. So this one's going to be pretty useful for a whole bunch of things. So the function of this is it stores the last digit. And then what we're going to do is we're going to need to add that to the reverse. So reverse is going to get the value of reverse plus digit. So I'm doing this kind of the classic way, and then we'll do a bit of a translation using assignment operators. So reverse is going to get the value of reverse plus digit. And so what we did was the first line stores it. This one adds to the reverse. There we go. Now what we want to do is we want to now take 4. Now there's really no good way to do this. Like we could write a complicated method to do this. But what we want to do is we want to use this modulus, and it can only take the last digit of the number. So what we want to do is, now that we've processed it and added it, we want to we want to remove that 7. So what we're going to do is our number 5 is going to get the value of number 5 divided by 10. So this is essentially just going to hack off that 7. So this one has removes last digit. Good. Okay. So we've got all of this done. Now the last thing that we want to do before we continue and get the 4 is I want to shift the 7 over so that we can have room for the 4. So what this is going to do is our reverse number, I want to multiply it by 10. So reverse gets the value of reverse times 10. And just to show you this working, we'll do a system.out.println. Let's see what our reverse looks like at this point. So at this point, we should get 70. So I'm going to run the program. We'll wait through this, and I've got to just shift my window over a little bit. There we go. So we get 70. We've taken the 7 off, we've added it to the reverse, and then we multiplied it by 10 so that this digit here, the 0, can now become the 4. Okay, so how are we going to do this? I'm going to leave this at the bottom so we can always see the last thing that we accomplished. So what's going to happen here now is we're going to repeat the process. So for the first one, I have to see, can I use an assignment operator here? Now I can't really do that because you only use it when a value is being changed by an amount or increased. But because digit is becoming the result of other values that aren't digit, we can't use an assignment operator. So in this one, can't use assignment operator. So try and remember that because digit is the result of something with these values, it can't be done. Now let's add on that digit, which is going to be 4 this time, to the reverse. So here, reverse, we're adding on the digit to reverse. So we get this pattern, reverse gets the value of reverse plus digit. So in this case, we can actually put in the plus equals. So we can put in digit there. Okay. And then the next step is we want to remove that from number 5. So here, number 5, we're editing the value so we can do a divide equals 10. And then we are multiplying reverse by 10. So reverse multiply equals, multiply equals 10. There we go. So hopefully you can kind of get a sense from this that if you learn how to use these, it makes your program a lot more easy to read. So if I run this again, let's see what we've got. So there we go. We've got 740. And then what we want to do is just repeat this over and over and over again until our result becomes 74285. So here's your challenge. The challenge is to repeat enough times to reverse the 5-digit number. So this is an algorithm that we need to just sort of continue. Obviously, this would be a great application for looped code, but we're just going to learn how to do the operations and work with the variables for this. So this is what you should do now is repeat this step over and over again until your 5-digit number is reversed.